Right, Master of Science students, let's proceed on from where we left last time. So uh, these systems, uh, there are new words which I think we're going to introduce. That's tetrahedral, trigonal, and diagonal. But just to relate to some terminology that you've heard of, like sp3, then you know in sp3 we're dealing with a tetrahedral carbon. If I'm dealing with an sp2, then I'm dealing with a carbon with a system whereby it's got a double bond and it is flat on a plane. The bond angles are 120 degrees. And if I'm talking about an sp system, then I'm talking about uh, it is linear and the bond angles are 180 degrees around that system. So diagonal is the same as sp, trigonal is the same as sp2, and then tetrahedral is the same as sp3. In this case, this is just familiar words for tetrahedral and also sp3. So now we are just introducing new words: trigonal for an sp2 system, and then diagonal for an SP system. So these are the rules that if I'm dealing with an exo tet for tetrahedral, uh, uh, please note that we don't put the long word tetrahedral, just saying the word tet. So from 3, 4, 5, 6, and 7 exo and then the tet, then you are saying all of those systems, they are favored that you can form, if you've got a nucleophile and an electrophile trying to form a ring system in which the one living is outside the ring which is forming, from 3 to 7 membered ring, it can form. There is no problem on that. And then if you're now getting a case whereby the group which will be receiving electrons is like the electrophile is now inside the ring which is forming a 506 membered ring, which are going to call exotet, 5 and 6 exotet. Sorry, they are 5 and 6 I'm using that word, sorry. Endo tetrahedral. These are uh, these are not favored, yeah. And then what you're going to see is that for a 7-membered ring, a 7 endotet is going to be favored, yeah. What you're going to see is there's a reason for this stoichiochemistry that when you're dealing with up to 7-membered ring, the group which is coming is going to allow a 180 degree between the nucleophile which is coming and the group which is leaving here. What you're going to see is that for the 3, 4, 5, for the exosystem, the orbital where for the one for the living which is going to be attacked by the nucleophile is going to have the favorable trajectory. So the nucleophile can actually attack that orbital very well with the group which is leaving, and there will be a good angle of 180 degrees, yeah, 180 degrees between the orbital and this other one. So, but for 5 and 6, you're going to see that for that orbital to be there, this one will not be able to be approaching, but for the 7-membered ring, it will be able to approach from the backside. What you're saying is that it's just like for SN2, there is the backside displacement with the Waldon inversion. If you're dealing with a stoichiochemistry, something like that. So the group which is coming in has got to be at 180 degrees to the group which is leaving. If there is not that trajectory, then the ring closure will not happen. But that one, I think I'm going to be discussing that one later. Yeah. So 5 and 6 endotet will not be favored, but with the 7-membered ring, the trajectory will be enough. Now, for the trigonal system, yeah, I hope I'm not very quick. If I'm quick, you can be able to stop and really rewind the video. This is the reason for the video system, that you can be able to even make it probably on the YouTube. You can be able to tell it, hey, you want the playback speed to be maybe like, instead of 1.0 to be 0.7, 0. Whatever, so that you're going to be hearing what is being said slowly by slowly. So in this case, you can see there is the ring system which is forming, and the one receiving electron is on the outside. So this EXO, yeah. So there's the double bond. So this 1, 2, 3, like this, from the 3 up to 7 member ring. I've not shown the ones in between here, but this 1, 2, 3, 4, 5, 6, 7, like this for a 7 member ring, and it is an EXO system, and it's a trig. So all of those systems from the 3 to the 7 member ring, they're all favored. And then you are saying, hey, how about if you have the group which is receiving electrons on the inside and there's a double bond? From the 3 up to 5 member ring, those systems, and it is endo, it means that it is in the ring, it is disfavored. 6 and 7, it means that that the bond that the ring will be large enough to allow this thing to actually come from the uh, uh, okay, you're going to get this that angle. It's by two gentlemen. I think it's Boogie doing it. I think I'll come to that bond angle later. But the 6 and the 7 systems are able to achieve the proper trajectory of allowing the nucleophile to actually uh, be able to form a good ring system, yeah. But the 3 to the 5, the ring is uh, the atoms are too far to be able to have the proper trajectory. And then for the diagonal system, I will start with what is surprising, that that all endosystems, the endosystem, whereby if you're talking about forming a 3-membered ring, 4-membered ring, 5-membered ring, 6-membered ring, and the 7-membered ring, whereby there is the triple bond, in which the nucleophile and the electrophile are in the ring, all those systems are favored. Yeah, it is easy to remember. 3 to 7, they are favored. In this case, we are saying for the EXO 3 to 7, they are favored. In this case, 3 to 7 endo dig, they are favored. But for the EXO, you're going to see 3 and 4 EXO dig are going to be disfavored, and then 5 and 6, no, 5 to 7 are going to be favored. So the last video which I'm going to be showing will be to actually show the uh, the favorable trajectories. That's going to mean, for example, all of these ones are going to be favored. These other ones are going to be favored. The ones which are going to be favored, we'll just try to see the favorable trajectories. Yeah. I hope whatever I'm showing is actually clear on the board. Yeah, that the is actually, it can be seen on the video quite well. I think everything can be seen quite effectively. Yeah, tetrahedral, uh, trigonal, and then the diagonal systems. Yeah. Okay, so I'll stop there, and then we'll move on to the final video of this Baldwin group, Baldwin rules. Okay.